In a solar system far, far away, a distant planet 124 light years away has shown us the first signs of potential life on another planet. In a recent paper, NASA's James Webb Space Telescope has detected methane and carbon dioxide in the atmosphere of K2-18b, an exoplanet that could possibly be habitable. If the results are true, then this opens up everything we know about the universe and how prevalent life may be. K2-18b is a planet 8.6 times as massive as Earth, orbiting a cool dwarf star called K2-18 in the constellation of Leo. It is located about 120 light years away from us, which means that the light we see from it today left the planet around the year 1903. K2-18b was first discovered by NASA's Kepler mission in 2015, and later confirmed by the European Space Agency Gaia mission in 2018. But what makes K2-18b so special is that it lies in the habitable zone of its star, which is the region where liquid water could exist on the surface of a planet. Liquid water, considered to be one of the key ingredients for life as we know it. So finding a planet in the habitable zone is one of the main goals of exoplanet research. However, not all planets in the habitable zone are necessarily habitable. For example, Venus. It's also in the habitable zone of our Sun, but it has a thick atmosphere of carbon dioxide that creates a runaway greenhouse effect, making the surface temperature hot enough to melt lead. On the other hand, Mars is also in the habitable zone, but it has a thin atmosphere that cannot retain enough heat, making the surface temperature cold enough to freeze water. So to determine if a planet is truly habitable, we need to study its atmosphere and look for signs of water and other molecules that could indicate the presence of life or its potential. This is where James Webb comes in. Webb is the most powerful and complex space telescope ever built, and it was launched in December 2021 after decades of development and delays. It operates in the infrared range of light, which allows it to peer through dust and clouds that block visible light. It also has a huge mirror of 6.5 meters in diameter, which gives it unprecedented resolution and sensitivity. Webb's first target for exoplanet observation was K2-18b, and it used a technique called transmission spectroscopy to analyze its atmosphere. This technique involves measuring how much starlight is absorbed by different molecules in the planet's atmosphere as it passes in front of its star. By comparing the spectra of different wavelengths of light, Webb can identify what molecules are present in the atmosphere and how abundant they are. The results were astonishing. Webb detected methane and carbon dioxide in K2-18b's atmosphere, as well as traces of water vapor and hydrogen cyanide. These are all carbon-bearing molecules which are essential for organic chemistry and life on Earth. Methane and carbon dioxide are also greenhouse gases, which could help keep the planet warm enough for liquid water to exist. The abundance of methane and carbon dioxide and the shortage of ammonia support the hypothesis that K2-18b may have a water ocean underneath a hydrogen-rich atmosphere. This would make K2-18b a Hycean exoplanet, a new class of planets that are larger than Earth but smaller than Neptune, with hydrogen-dominated atmospheres and water-covered surfaces. Some astronomers believe that Hycean worlds are promising environments to search for evidence of life on exoplanets. Webb also detected a possible hint of dimethyl sulfide, DMS, in K2-18b's atmosphere. DMS is a molecule that on Earth is only produced by life, mainly by phytoplankton in marine environments. DMS plays an important role in Earth's climate by affecting cloud formation and aerosol production. If confirmed, DMS could be a biosignature, a chemical marker of life on K2-18b. However, before we get too excited, we need to be cautious and skeptical about these findings. First of all, Webb's observations are still preliminary, and need to be verified by further analysis and independent confirmation. Second, there could be other sources of methane and carbon dioxide on K2-18b besides life, such as volcanic activity or chemical reactions. Third, there could be other factors that make K2-18b inhospitable for life, such as high radiation from its star or strong tidal forces from its neighboring planets. So what does this mean for the search for life beyond Earth? Well, it means that we have found a new candidate for habitability among the thousands of exoplanets that we have discovered so far. It also means that we have demonstrated Webb's incredible capabilities for exoplanet exploration, and that we can expect more exciting discoveries in the future. It also means that we have opened a new window into the diversity and complexity of planetary systems in our galaxy, and that we have to expand our imagination and curiosity about what life could look like on other worlds. But what it really means is that there is life, even simple life, somewhere on one of the limited planets we can actually investigate. Then the possibility of an alien civilizations not only becomes probable, but a certainty. If life happened on more than one planet, then life really is everywhere, and maybe, just maybe, the galactic empire really is out there. But what do you think? Do you think we've discovered life on another planet? Is there life everywhere that we just can't see yet? Or are we all alone in this dark universe? Let me know in the comments below. Please like, share, and subscribe. It really helps out a small channel like this one. And thank you so much for watching. I will talk to you next time.